Sure. Just hold a second, please. Okay, so you can see my presentation now.
Yes, no.
Okay, thank you. So, well, hello everyone. Let's start with the first paper of the day. It's called a survey on HCloud, where we are going to review about 4 new models or paradigms. So let's start with this little agenda. We are going to see introduction, and also, well, I guess in the second point, we are going to spend, I guess, the most part of the presentation. And after that, we are going to review some features based in the 4 paradigms that we are going to review in the point number 2. So let's start with the comment or with this statement. So where it says that sending data to the cloud is the main option that we know in order to have it analyzed. So that's true. In fact, before read this paper, I was thinking that everything was done mainly in the cloud, and well, there were no more options. But as we are gonna find out, there are some new approaches in order to compensate or to have all the data be analyzed. So first of all, we are gonna check about the motivation about this paper, and well, it says that at the beginning that there are some issues, I mean capacity issues regarding the infrastructure and the performance about sending all the information to the cloud to be analyzed. But which are the factors that produce these constraints? Well, mainly it's because there is information exchange in people's daily life, and well, that's true. I guess everyone is in every time in the internet looking or working on it, or maybe just checking the Facebook or YouTube or whatever. And also there are interconnections, not just between a person and a device. Also, we are talking about, or right now, about interconnection between devices. Also, one of the main factors that are requesting a lot of resources is artificial intelligence, also intelligent science, and well, mainly IoT, all the devices, sensor actuators, and mobile devices. All of these are requesting resources from the internet, from the networks, from everything. And also, which are the main products that we are looking for in order to have all these resource consumptions? Well, we have what it's called virtual reality, also augmented reality, and industrial control. These are just 3 examples, but I would add to this list maybe multimedia. I mean, videos from YouTube or maybe TikTok, whatever. Also, they are consuming resources from the internet. And well, I have this value statement, and it says that processing massive data traffic is a key feature of future internet and wireless communication systems. Well, and this is because we have 2 constraints in our daily basis about high data rate and low delivery latency. I mean, process the data and also transmission it, or transmission it. So I said, anytime we are working and suddenly our device stop working, we just think about this to this. Well, at least myself, that I'm not a technical guy. Well, I am just thinking about this. Somebody else is taking all the bandwidth, and well, my information needs to go pretty far and then go back, and this is causing delays and everything, and my device is not working properly. And also we have this value statement that also the centralization of computing resources in cloud facilitates resource management and maintenance. There are difficulties for cloud computing to satisfy the service demands of the new trend of the less sensitive application in the IoT era. Mainly this means that there are constraints about processing and with the transmission of data. But according to this paper, there are new models that are emerging in order to solve or try to solve this pair of issues. And we are talking about these four proposals or emerging paradigms or maybe new models that the paper is going to talk about. We are going to review transparent computing, mobile edge computing, fog computing, and cloudlet. These are the four, I guess, main items that the paper is talking about. And well, as said at the beginning of this class, this paper is not easy to understand. So in order for me to have a better comprehension of it, I went through the references stated by the authors in order to find more information about the items. So I have more information, maybe a better comprehension about what is the paper talking about. So let's start with transparent computing. So for me, this one, I guess, was the more difficult to understand for me because I didn't get at all the concepts and the reading from the paper. So I am trying to explain it. And well, this transparent compute was proposed to decouple the software, including operating systems, from the heterogeneous hardware of IoT devices. And well, characteristics are working on the client server mode, dynamically executing cross-platform services, and locally executions. This sounds maybe in the traditional way, working on a client server mode. I guess every one of us working this way. This dynamic of executing cross-platform services could be sort of familiar. And locally execution. Local executions, I didn't get at all that term. And well, I went through this illustration, but also it's too complex for me to understand. So I went through one of the references notes where I found this illustration more easy to understand is the reference 173. And well, here in the top part, we can see the traditional computer architecture. It says that we have a device. This device has storage, maybe some computer resources, but mainly the computing is performed in the cloud. This is the traditional way. On the transparent computing, what is proposing is to have a device without any without any storage on it, or in it, no storage in it, even no storage for a operating system at all. So this moved me to think about this, how you can turn on a device without an operating system. And in this paper and this reference, we have MRBP, multi-remote booting protocol. That's how a device without storage, and when it's turned on, you download from the cloud software, data, and everything you need in order to work with your mobile device. And also the most interesting thing is that all the computing is performing your device. So you don't need to send information to the cloud and wait for it and have it come back to see a result or an output. everything is done in your device, so the delay times are reduced, so you can have information almost in real time. Also, in order to have all this information downloaded from the internet, there is NSAP, Network Storage Access Protocol. So this, per my understanding, this accelerate or boost the downloading of the information that you need in order to work. Also, an interesting point is that when you download software, you don't load it at all. You download just the part you need to work in that moment. So also this optimizes the users of the interconnections between your device and the cloud. So at the end, you can see the reference I used, the 173. So let's move on to the second proposal, and it is mobile edge computing. This mobile or this proposal is easy to understand with this illustration. Maybe this illustration is looking pretty much familiar to you. We have devices, we have base stations, a cloud. But what is the magic here down here is this. I am looking what I'm showing with the cursor, edge servers at the base stations. That's the magic. So with these edge servers at the base stations, you have compute resources closer than if you send all your information all the way to the cloud. So for edge computing, that's the magic. Also, the objectives of mobile edge compute are the following. The first one is optimization of mobile resources by hosting compute-intensive applications such as image processing and gaming. So these are two pretty good examples for what mobile edge computing is used for. Also, as you can see in the list, the objectives are mainly optimization, enablement, and providing context-aware services. So let's continue with the following paradigm, and it's fog computing. I have this statement, I guess it's from one of the references. I guess it's not in the main paper. I guess it's one of the references, but I like it a lot. Fog, simply because fog is a cloud close to the ground. I guess that explains a lot about what is fog computing. And well, I have to say it's pretty similar to the previous one, the mobile edge computing, because close to the edge, you can find compute resources. But besides compute resources, you can find storage and networking resources. So you have closer to you or the end users all these three main resources you need to work with a cloud: compute, storage, and networking. And the usage is well, I found a pretty good example with smart cities. So with a smart city, you need a mesh and a lot of compute resources, but you also need storage. So I guess because of it, the edge mobile computing is not enough. You need a fog computer in order to have a smart city, and well, maybe to have vehicles connected to it so they can go through the streets without a driver. And also pretty basic example is the intelligent traffic lights. Maybe it sounds too simple, but according to this to the paper that I read, traffic light even needs a lot of resources. So I mean sensors and all this IoT stuff, so it can work properly. And well, the next one and the final one is Cloudlet. Cloudlet is a room or where it's a micro data center that is placed with proximity to mobile users. The example is a habit have this micro data center in a coffee shop or maybe a classroom. The motivation of the Cloudlet or to have it is to boost the interactive performance of mobile applications. I get well this illustration down here. Well, here in this model, the magic is to have these cloudlets. Oh, sorry, I am. Well, have these cloudlets show in yellow, and well, mainly all the resources you need you can find over there. But if in if in a time these resources are not enough or the capacity exists to the demand, some of the tasks can be offloaded or sent to the cloud. So with these rooms, you can have or find enough resources for your applications. And well, cases of use is the assisted driving support, and also sports training assistance. Also, in a reference that I read, I know well it said that face recognition is not a good example or a good feature that have enough resources for the cloudlet or in the cloudlet. And also speech recognition is not, well, the cloudlet is not going to have enough resources to, to achieve the in my personal appearance or my personal opinion, I would say the cloudlet has not enough resources for pretty complex tasks, but well, it's also another way to solve these resources need or yeah, these resources need from the cloud. Well, right now, well, here in this slide, we can see some similarities or differences between the items we have reviewed. And well, similarities, well, I guess main of them, the models we have reviewed, move resources closer to the users. I guess that's the main similarity. Differences, well, obviously the cloud is a centralized infrastructure, and well, for example, the transparent computing is the only one that offers or moves to have all the compute in your device, in your hand, maybe in your hand. The rest one have closer, well, the resources are closer to you, but maybe not in your hand. And also we have some criteria to evaluate each of them. We have some indexes in order to review the efficiency of any of these proposals. Support heterogeneity. It means support any kind of hardware, any kind of software, quality of service, also need for elastic scalability, pretty important. When you have a peaks of demand, you need to escalate it as soon as possible in order to supply it. Mobility support, pretty important, and federation and interoperability. I guess this has to be with interconnections between platforms, between brands, so everything can be work in one manner or as you need. Well, let's continue. And well, another point of this paper, or the main points, in fact, this is the third one, is computation of loading for emerging computing paradigms. In this part of the paper, we review three important points. That is minimizing energy consumption. Also, it's minimizing the delays. And the third one is to synchronize the minimization of energy and also the minimization of the delays. So in first instance, with the energy consumption, I also need to take some information from a reference. In this case, reference is the 24, where the author proposed this code in order to how do you say it? In order to prioritize the use of energy. I mean, author says that the platform as a service is a pretty, well, consumes a lot of energy. So with this code, what it's trying to do is to to get energy from a green power source in order to attend all the tasks for a platform as a service. On the other hand, we have software as a service. According to the author, it's not too much power consumption on it. So they use a brown source of energy. A brown source of energy refers to a traditional source of power, maybe some with oil, some with charcoal. With this code, it tries to prioritize from where the data center is taking the power. Also, another reference used for my learning is this one, the 65, where the author talks about Phi Y. What is this? It says that between the transmission of data from maybe a mini data center to the cloud, some of the tasks are moved among Wi-Fi. This is a pretty much consumption energy, and he proposed to have also interconnections with fiber optical resources like an optical cable. So the main task, or maybe the most strong task, or the most consuming energy task, are moved through this cable. So the consumption of energy could be take it down. So we have this couple of examples about energy consumptions. Also, regarding minimizing the delay, well, we have this proposal that works mainly as the cloudlet. In fact, it looks like the cloudlet proposal that we see before. But besides to propose use the resources of the cloudlet, the delay of use, the delay is minimized because we are using cloudlet resources instead using the cloud infrastructure. But as I said before, if there is any time when the capacity is not enough to support all the users in a cloudlet, some of the tasks can be moved to the cloud, so you don't see any degradation on the service. But as much as you can use the cloud resources, the delays are minimized. For this chart, I used the reference 89. And well, the next one is the joint operation of energy consumption and delay. For this, also, in order to understand better, I use another reference. In this case, is the 85, where the author proposed the ternary decision maker. What is this? This is is a proposal where the decision is based on estimated execution time and energy consumption. So there are tables, there are information used to perform a code. Well, I put down here the chart, but mainly the proposal is to have a system that runs in the background. I mean, the TDM, or the ternary decision maker, is running in the background. So it takes decision about how the operations are flowing among the data centers, maybe with the cloud and everything. So mainly the proposal is this one: have a system taking the decision which is the best way to perform an operation with the minimize the resources of energy. To a better comprehension, this proposal decides if a task needs to be sent from your device to the cloud, or maybe perform the cloud, to perform the computing in the same device, maybe with your microprocessor, or maybe with the graphical unit, depending of the kind of task you need and about the power consumption. The system is going to decide where to perform the computing operations. So let's continue. Well, we have the fourth point in the agenda, caching for emerging computing paradigms. This is pretty interesting because in order to have the delays reduced, there are cache installed in some parts of the networks. But where to decide to put it or to put them? Well, it depends. It depends, and well, we have in this chart or illustration examples that show how the cache can reduce the duplicate or to send duplicate. Maybe in this case, I will take the example as videos. With cache, we can, or maybe the network can save to send duplicated videos, maybe to users that maybe are too close. Well, in the first chart, at the top left part of the illustration, we see an example with no cache at all. Please check the green and the black lines. The black lines are duplicated videos. In this case, I am taking the example with videos. So the black lines are duplicated videos. And in first instance, in the right top part of the chart, we see the effect of put cache with the operator, with the network operator. If cache is placed over there, you can see a reduction in the black lines. So you need, well, with the cache, you need to send less duplicated videos. But in the down, you can see that the black lines are still the same. You need to place or put cache in the stations or the transmission stations. I mean, with the RAN, RAN, radio access network. If you place cache over there, you can see the duplicated videos are less in this example. And in the final instance, there is something called device-to-device cache. And well, at the time when this paper was released, this technique or proposal was still under review or maybe under investigation. So there is no change, but well, there is no change in the chart, but what the proposal is to place cache in the final or end devices. So this was the cache strategies shown in this chart. And well, the next point in the agenda is the security and privacy for emerging computing paradigms. Well, it says, well, it states about security. This paper was released in the 2019. So the systems, well, it takes or the paper reviews the security items from two main point of views: system level security and privacy, and service security and privacy. For the system level security and privacy, it proposes continuous monitoring of the network. And well, from my little experience on cloud, there right now there is something called zero trust that is in fact that proposal continuously reviewing what is the devices that are connected into the net or the network in order to define if they are friendly or if they are an enemy. The second approach is the service security and privacy. It talks about authentications, privacy preservations, access control. Well, it's not in the paper, but right now is something called SASE, Service Access, Service Edge. For my understanding, there is companies that works on this kind of solutions or platforms that connects to the cloud in order to have these points that the paper talks about: authentications, access control, and everything. So let's move to the next point, future research and directions. Well, mainly the paper says that the direction of these tendons or these models is to virtualizations, communication between platforms, the uses of APIs, also in order to have all the devices, all the hardware communicated among them. Flexibilized network operations, obviously, because there are need of, to communicate or to connect without any much trouble for the end users. And well, conclusion, because I am almost over the time, conclusions is that the common feature of a computing paradigm is to orchestrate the computing and the storage resources of end devices, edge servers, and the cloud improve the performance of hierarchical IoT systems. So I guess I almost took the 30 minutes, but well, this is my review or my presentation about this paper. Hope you found it interesting.
Thank you so much, Gautier. It was interesting. I know the paper has a lot of information, and it's nice to see that you're going out of the paper to find basically to understand it better from the references. So it's open for discussion, question, answers. Who was the discussion leader for this?
I am Mavi.
Okay.
Okay, hi everyone. So questions. So, well, first, any specific question that you have?
Yeah, I have one.
Okay.
Okay. Well, it is supposed that those paradigms, I don't know how to say, paradigms are more used in IoT. So the people that was in the, well, a lot of the persons that are here were with me in the IoT course the last semester. So what do you think? Well, we and most of us were using LoRaWAN as one of the networks that we were using. So what do you think is which of these paradigms are more related with LoRaWAN?
Well, in fact, for me, my first approach was the same. I thought about this IoT class that we had last semester, and I was thinking that IoT was pretty much about the paper. But while I was reading it, and also in the references, it states that IoT devices, there are a kind of IoT devices named mobile devices. And these mobile devices are also smartphones. So, oh, gotcha. That's why this paper talks about a lot of bandwidth, about the importance of the reduced delays, because by my understanding, nowadays, the larger quantity of IoT devices are the smartphones.
Yep, but from those paradigms, the paradigms that you presented, which one do you think is more related to LoRaWAN?
I guess the cloudlet, and because it said micro data centers. For me, with LoRaWAN, I guess the micro data center is this device that takes the signal of an IoT device and send it to the core of LoRaWAN.
Okay, I was asking this question because I think the same. I am not sure if this is the cloudlet or the fog one. Maybe one of them is more related to LoRaWAN, but I am not totally sure. So that is the question that I am doing.
One question, Pedro, in this case. Sorry, Gautier, were you going to say anything?
Oh no, go ahead, please.
Okay, so I wasn't in that meeting, in that subject related to IoT, but can you briefly explain what is IoT?
LoRaWAN is a network that it's a free network that normally is used for IoT devices. But in this case, you need to have like some kind of gateway. Once you buy the gateway, you have access to the full LoRaWAN network. But the thing is that you have like a reduced account. You don't have all the privileges. So if you want to get like more requests that you are allowed, you need to pay for that. So yeah, that's I think LoRaWAN needs to use one of those paradigms that were presented by Gautier, but I am not totally sure which one of them.
So it is a network, right? That's what you said. Okay. So in the paper, it mentioned transparent computing that was more related to IoT topics, right? Those were the main, like, the questions for transparent computing were related to IoT. And one of the questions that I found interesting about transparent computing was that currently in the current market, there is a lot of operating systems for IoT devices, right? So one of the main questions, well, one of the future questions was if we could implement the same like solutions that we have for example, Microsoft Windows and Linux for virtualization to homologate, kind of, well, provide flexibility to every operating system, right? And also there is a different solution for, instead of using virtualization, we could use something called block streaming, which is like sending, well, a main server will like send operations or operations to the IoT devices, right? And the IoT devices don't have to load all the software at once, right? They just get one instruction and they can execute those operations immediately. So one question that I would like to discuss is, what do you think would be better, if a virtualization perspective or a block streaming solution to try to homologate like IoT devices and get like the full, seeing it just as one unit, right? Not just like multiple IoT devices with different like operating systems.
Right now, there is a big push on going everywhere like towards virtualization and having like a standardized like container running on top of any Linux-based operating system. For example, we have like this initiative that is Home Assistant that is very linked with the Matter standardization protocol. That is like an effort from different providers like Google and Amazon that are basically do tons of IoT. At the beginning, Home Assistant was based more on block streaming. I mean, it was like kind of similar to transparent computing in the sense that it was grabbing resources like computation and output and input from the network. But right now it is moving a lot towards like everything virtualized, like taking into like very in itself being more like a brain. It is kind of strange. I don't know why they are going like with this proposal. I think that before it was better, but I don't know. I mean, I see this one being followed a lot, and it is becoming more and more common because of this this Matter initiative that Google and Amazon and Apple, I think, no, Apple is not there. I'm sure that he's not there, but other companies are just like getting in agreement that everything should be virtualized in that sense.
Well, I think that it's been the paradigm, the problem that you have, right? Each paradigm try to address one different problem. In the case for transparent computing is that you have like a lot of devices with different versions, different hardware, different software. So the transparent computing is trying just to in some way try to work with all of them without doing extra effort. So I think maybe something changed with that part that you said. So for that reason, they changed the paradigm that they are using for working with that.
Yeah, and I also guess that it's not a thing of like competition, right? It's not like we will just pick one paradigm and just stick with it like for our entire life for every like edge computing solution. Like for example, Netflix, right? Netflix has its like Open Connect initiative that, I mean, it's only storage. Why does it even need like processing capabilities? I mean, it's Open Connect thing. What it does is that it caches like very popular content in nearby service providers. That's why usually the content that is like very commonly accessed by people in a same region, it is faster to get loaded. That also like relieves a lot of the traffic in the backbone of Netflix. So yeah, I mean, I think we will keep like tons of paradigms. Some of them will become more common, but it really I guess that they do have some different advantages according to the application.
Yeah, but I think those services that are more related to streaming, they have like paradigms more related to quality of service, right? Because the service needs to be the high priority in the network.
I think it is.
So you mean at the end, we don't need all these paradigms, Pedro? You mean they are not going to coexist together, or?
No, what I try to say is you have in this case we are studying like four or three, I don't remember, 4 or 3 different paradigms, and each company is going to use the one that solves their own problems. So there are some paradigms that are more focused on QoS, quality of services, QoS, and there are other that, like we said, that are more they want to save energy, for example, electric energy, right? So it depends the problem. Depending the problem, is the paradigm the company is going to use. I don't know if there is a possibility of using 2 paradigms or more at the same time.
That was my next question actually. Some of these paradigms seems to be like interchangeable. You could combine them, right? For example, the Clouded provides you like micro data centers, right, with computing capability. And also like now for IoT, for example, we have the virtualization and also the block streaming. But do you think we can combine those like those paradigms together? For me, I think the answer is yes, right? You just mentioned some that it depends on like the problem that we want to solve, but what do you think about it? How would you combine those paradigms? Probably Clouded plus, I had an example. Yeah, Clouded plus block streaming. I personally find block streaming interesting. Just like send some instructions to IoT devices, and they don't have to store anything. They just execute them. But anyway, what do you think?
I think well, on IoT devices, it depends on the application that Rodrigo mentioned. But for example, at your house, if you have an Alexa from Amazon, and also you have lights, some devices measuring the environment at your house, of course, the user can use the smartphone and just review the environment. For example, oh, okay, the temperature is 35 degrees. Okay, my lights of my room are turned on, so I need to turn them on, And well, at that moment, Amazon is gathering all the information. So just when you said, "Hey Alexa, buy a new light bulbs," it's like they are two things are working at the same time. I mean, you just a user, you have all the information you need in real time, but Amazon is gathering all the information, so they are processing everything, and even the device is also listening to us. So it's learning from us. I think both things are working at the same time. So it's not an conspiracy theory or something like that. No, but I'm trying to say that maybe it's working at the same time we can see it. They have been doing that for maybe 5 years. We don't know about it until now.
Yes, you're gonna do like a basic instruction, like just turning on a light in a specific time of the day. It's like a basic instruction, so everything can be run on the edge. But now, if you want to do like I don't know how many people, I don't know, gather all this information of how many people turn on the lights in a specific time of the day, regardless of the time zone, and combine a lot of different data, probably you want to use the cloud. So you can combine paradigms depending on the application you want to do. But you need like an orchestrator, I think, like that.
Anyone else?
Sounds good.
Yeah, the idea is again based on the requirement, right? I mean, the requirement on quality of service, delay, processing, storage. It's not, the idea is not you doesn't need always rely on cloud. There are certain data that can be processed locally, certain can be processed cloudlet on edge, on fog, and then on cloud, right? So it's like, there's no point to just rely on cloud for everything based on the requirements. So you can go with any of these basically paradigms. And I believe so. And at the end, they're all going to coexist because I mean, I can't see a future that we just rely on one of this technology, right? That doesn't make sense. I mean, we can just coexist. They can all work seamlessly together without any problem. I mean, why something that can be processed on my smartphone or an IoT device locally should be go to cloud and come back? Doesn't make sense, right? And again, for some theoretical barrier, we cannot rely purely on cloud for, I mean, the speed up and the delay, right? So we need to do certain things locally on edge and that's my 2 cents.
Yeah, and also that brings to the security awareness that from the paper and the other documents that we have seen, most of them focus on the security because after all these challenges with the energy, the performance, the small resources, the weather conditions, as the example that Pedro mentioned from the last semester, we had this free version of the network, but in that case, we have to share our device to repeat the network signal with other customers and broadcast if necessary. So apart from solving all those kind of challenges, this is the next step, which is the security. And I'm sure we'll see more of that on the next presentation. So
okay. Okay, great. I don't know if there is anything else. So thank you so much, Gautier. Just please don't forget to include your presentation link in the spreadsheet. Because I see you haven't included the presentation link. This is just for everyone to have access to those presentation later on. So I think we can, thanks. I think we can have 5 minutes break so you can grab a glass of water, beer if you want. Not necessarily for that. Whatever you want to drink, whatever.
That's tequila.
And we come back by 7:43, okay, to continue.
Thank you.
Okay, thank you.
Thank you, Maddie.
Actually, during the break, I forgot to pause the recording. So later, if you check the recording, you're gonna see my face for like 10 minutes. Sorry, sorry about that in advance. Yeah, you can go ahead, Fernanda, you can share your screen.
Okay.
You also forgot to include your presentation link. Later on, you can do that.
Okay.
Yeah, go ahead.
Sorry, I have to give permit to my computer to show the screen. Give
Okay,
me
sure.
a minute.
And then for the next break, then I have a good news for you. So you can wait for it.
Dun. Tell me if you see something. Sorry. Sorry for getting you dizzy. I'm going.
We can see that it is over zoomed. Yeah,
Yeah, sorry.
it's okay. Yeah.
Okay,
Ah,
now
so-
you see?
Yeah.
Ooh, okay. I don't know, my lights getting dark here. My lights turn on, and I don't know why, but okay. Okay. Before I start, it's necessary to give you some context of the problems we are facing today to understand the concepts and the paradigms. I also have problems pronouncing that word, paradigms that my paper discussed. So there is approximately 5.1 billion people that use internet every day, and around 1.92 billions of different websites on the internet, and approximately 4.2 billion of individuals that use mobile devices to access the internet every day. The authors of my paper say that it actually was written in 2019, so it wasn't that long before, said that by 2012, there will be a more than 50 billion devices connected into the IoT networks worldwide. And well, I did a quick research for recent statistics, and now they say that by 2025, this number will now grow to exceed approximately 75 billions of connected devices. If you need a comparison to measure this magnitude, it's more than 10 times the worldwide population in just devices. And we are not talking about people that occasionally send signals or messages just when they use their apps. We are talking about the IoT devices that are generating and processing data and new commands or new analytics every second, all day, all night. I mean, this is impossible. It's almost impossible to imagine the amount of data that we are creating and processing every passing second, not minute, nor hour, every second. Without mentioning the storage space we will require to store this amount of data and the power it requires to be processed. It is, this is where the authors of this paper analyzed these three scenarios and came like the wizard from Zelda to propose these three paradigms. I don't know if my animation, yes, my animation is working. Propose these three paradigms that in combination are very useful. Basically, these three paradigms are the cloud computing, the fog computing, and the edge computing. Let me see that it's well connected. Okay, it does. Sometimes it takes a little while to proceed. Okay. We are gonna go with the first one, the cloud computing. Cloud computing changed the way that we approach to develop of applications and the use of those applications by itself. Basically, it gives us these two biggest greatest advantages, that is the computer on demand and the fast implementation. What does the computer on demand is? Well, thanks to this, it gives us a massive amount of computer power, all located in the cloud, and it also gives us instantaneously access to all this power. Basically, all the power you need in a location you might need it, because cloud computer can change the cost involving developing these applications. Basically, instead of creating your own data. And instead of creating your own data center and purchase your own equipment, you can simply buy some time on a cloud-based service. Basically, it's the pay as you go. So it's very useful for small startups, small businesses. It was really nice when the cloud computer coming to the world, but although it is changing, right? Okay. Although cloud computing provides us significant advantages, as we saw, there are some disadvantages as well. For example, cloud computing is not always the best solution. The cloud might be at a location that is not near you. So there might be some delays in the communication between your device and the cloud. And there might be also limited bandwidth since this is going across the wide areas, trees and buildings. So it can have like this big latency. As we saw in the other class, it might also be difficult to protect the data because when you purchase this service, you're required to be in the same, well, how can I say this? Sorry. You need to follow the cloud service provider and it might not be allow you to do this kind of encryptions or security processes. So I remember that I said the last class, like, well, you just have to do an encryption, but no, some services doesn't let you to do that because that's how it was built and you purchase that services, so you need to follow that service as well. And of course, because these applications are located off service, in the cloud, if you have connection problems, you won't be able to communicate with that cloud service. So basically all your power of processing your data will be lost. And well, those are some disadvantages. In recent years, we have seen an enormous increase in the number of IoT devices. That's where we are gonna see the edge computing. Today, it's not unusual to have climate controls, smart lightings, or like camera system in your home, running inside in your home. So basically that we can control with just the tip of our fingers in our cell phones. Well, we have to know that a lot of the data of these devices a lot of the data that these devices are generating and all the decisions that are occurring on the devices that itself are happening inside of their devices. You don't need to go to the cloud to do these kind of things. We call this the edge computer or just edge. This means that applications that are running and the decisions they are making, they're all are occurring in the local system. I don't have to go out of the internet because imagine that's what I say in the other meeting, in the other paper, read, that if you just want to like turn on and turn off your light, well, that's nothing really complex because it's just an instruction, a really direct instruction that you don't need like a very complex calculation, or you don't need more information to just say like turn on and turn on your light, or even put in a more complex thing like, okay, turn your light at 10 a.m. in the morning. It's not that really complex. So probably all this information can occur in the edge. It's faster, it's secure because, well, no one can see that it's just you because it's in your local network. But now imagine this, well, imagine that you are the cloud, because as Pedro said, we can combine paradigms, but do we need to do that all the time? No, because if you do this, for example, if I want to turn on the light using a cloud server, well, I have to send the message to the cloud. The cloud needs to process that information and then send the response to my home. So it's not really that necessary. It takes more time. Actually, if you have this huge light system, you can try them. It's faster to turn on and off your lights with the direct application, but it also gives you the opportunity to link into the cloud. But even when you're in your home, it will take like 10 seconds more. And I know that 10 seconds is not that really too much, but well, it is too much when you are trusting in your car braking system to, I don't know, save the life of a person. So probably these 10 seconds would be really necessary in those situations. And well, probably you have seen that episode of Big Bang Theory where Wolowitz opens a public control and uses the cloud service or satellites in that moment to turn on and off the light. but the internet starts turning on and off the light like really randomly, because most of the time it's open and people can access into that kind of system. So it's not precisely safe to use most of the time the cloud. But that's the reason sometimes we use the edge. Edge computer gives us two amazing and simple advantages, that is connectivity and performance. Since there will be no requirement to communicate this data out of the internet, we don't have to worry about the latency of any type of wire area networking. Connectivity is really on your local network. And also it means a better performance because this device is running, as I said, locally. Sorry for if it's a lot of time the same word, but basically the speed and the performance is going to be as the same latency or speed of your local network. So it's better speed and performance. But of course, not everything is just about to be quick, or, like, it's not just about to be quicker for other systems. We should also think about the data perspective. All of those Internet of Things devices, like your garage, your climate control, your lights, are all connected are collecting data. And if we are already collecting a lot of data, well, of course, we want to use them wisely and make our devices smarter. We just don't want to turn on and off our things, right? So this is where the fog computer comes into play. Now that we have the power of the cloud computing and the performance of the edge computing, we need something in between to give us the power to have the data locally, but also be able to manage the things in the cloud base and still be able to orchestrate all this power, manage and optimize all these resources. So yeah, that's when we use the fog computing, the distribution that allows us to send information into the cloud for processing without require us to send the whole data set into the cloud. This means that any data that our IoT device need to make local, the local will be local, but we can say, okay, leave all the unsecure or more private information in the edge and send the rest to the fog. And in the fog, I will decide, okay, this information can be in a bigger data set that it's the cloud, and I can do a more complex processing to, I don't know now, create a smarter device, but still be able to do other decisions quicker in my local service, basically. I think you already got it, but I will just quick recap. Thanks to the edge computer, or edge computing, gave us these two great advantages, that is the distribution and the security. Basically, the distribution, any data that is in our IoT device need to make local decision will stay in local, and the rest is going to be on the cloud, being more complexly, sorry, I forgot how is the word, but it will process more in a more complex way. And the security, because I think also Pedro said the last time, well, we can leave all the security information locally and then send the rest that I don't really care into the cloud and be more complex processes. And I think you already got it, but if you're a really visual person, here is a visual representation of that map. I hope it's not too little. But just to make a really quick example of this, let's look to all the devices in the lower part, such like your automobile, your bulbs or AI system, your computer, your cameras, etc. And let's say the car. Inside of the cars, we have 1,000 different CPUs that are collecting data. Like about our tires, our suspension system, our braking system, and all of that data is being collected locally in the edge. And probably some of this info doesn't need to leave the car because we are using some quick decisions, okay, tell me when I need to fill up my tank, or tell me if my tires are already getting wasted, so I need to change those. So yeah, and that kind of things. But there are circumstances where we might want to send some of that data into the cloud to be able to consolidate them and I don't know, to make other kind of decisions. So I send those into the fog. In the fog, there will be some nodes that will be controlling the resources, will be creating the standardization or cleaning those information, and then I will send it to the cloud so I can do a more complex instructions. Like now I can compare my information with the other 1,000 millions of cars there is in the world, so I can create more interesting statistics. And yeah, basically those are the three main topics in my paper. My paper compares these three paradigms with many other paradigms. But you can check this table later. I decide to only talk about the cloud, the fog, and the edge, because they're all like the most basic ones. And probably if you start reading about the other paradigms, you will see that they're almost kind of the same. I mean, some of them are more focused in cell phones, some of them are more focused in controlling, I don't know, the amount of energy that it requires to be used. I mean, each one of those are focusing in on specific things, but the basic one, or at least the more famous one, are the fog, the cloud, and edge. And yeah, as a conclusion, this is my conclusion: having a local processing on the edge of the device and having a midpoint in the fog allows us to have a much more efficient cloud computing experience. And yeah, they complement each other, because you will see a lot of posts in the internet that says that they are constantly comparing those, like cloud versus edge or edge versus other paradigms, but they really are complement each other. They're not in fight. You can use it, you can combine, and you can use the best thing of each other, but you always need to really understand your problem to see which one of these paradigms will help you to create a better solution. And yeah, it's very basic. Thank you. Sorry if I get nervous. Even when I'm in the United States, I'm still nervous about my English, guys.
No, thanks a lot, Fernanda. It was
Thank you.
It was great. The animation was like, I don't know, you were not probably seeing the chat. Everyone was like screaming about the presentation and animation. When do you have time to give us a class about preparing something like this?
It can also be like a trick, because if it doesn't happen the way I want, then it will be like, oh, well, imagine that there was an animation.
Seriously, I can cancel one of the papers. So
yeah, the next one.
Yeah, we can learn something more useful. But it was great. Later, I really look for you to see how you do it. But let's continue with the discussion.
Be gentle with the questions, please. I didn't study this.
Actually, I think it was, it's a big paper. And what you said is like, wow, it's so easy to understand what you were saying instead of reading the full paper. I think that was a good presentation, actually. Besides the presentation that you are doing, that is amazing, your work as a presenter was really very good.
Thank you, guys.
I have a question.
Go on.
When I read the paper, it says that it made like a lot of comparisons between fog, edge, and cloud computer. But my question is, like, you can use only like edge computing or fog computing, or you have to use it the third of them?
Normally, they are using, as I said in the comments, I think internet uses like the three musketeers. I mean, this is like the classic three combo, and it's really good using the IoT system, but it depends of the product you are creating. I mean, I tried to read really fast the other comparison, because really the paper compares every single paradigm between each other, and it gets really like technical. Again, my lights is getting off, sorry. but yes, you can use it, you can combine it in your own like necessities. You can even use more paradigms, not just 3 or just 4. You can use as many as you want depending of your system. You need to understand your problem to be able to know which one to use. But these are like the perfect combo, like the most used combo outside in products.
At the end, it's like a network layer, right? Almost, not exactly network layers, but it's like about size. Like, for example, the cloud is like the biggest and the fog, and you go to smaller networking like systems, right? Well, network connections, I don't know how to call it. Yeah.
Yes.
Yeah.
So at some point in the paper, the author mentioned that also in another papers they use a synonym, all these paradigms. But that's one of the reasons that he makes a summary of the advantage and disadvantages of them and how they work as hybrid system, just for people to understand all those small differences at the time that referring to each one of the terms.
Yes, I mean, I didn't study, or I have never taken not an internet class, like how the connections work, but just like reading the paper and searching a little bit in internet, it does is like the layers of the connection. It's like your local connection, something in between that will be like the border, like what things you want to cross into the into the cloud, and then the cloud that it's more complex and it normally has more structure and it's more complex and bigger, and basically that. I don't really know how it works or which technologies you use to use them, but I know that you have to understand how they work and in which situation you need to focus in each layer. That's what I learned from the paper. Sorry. Sorry, bye. Sorry that I'm still working. Yes. There is another question. Okay. I don't know if there are questions.
Yeah.
Christian,
Yeah. So if there are no more specific questions, one of the questions that I have prepared is, does anyone has any example of the devices that you own, maybe at home, that have experienced any lag, as Fernando already mentioned with the lights? I don't know if there are any more examples.
I do have one that is very interesting. I mean, I had a smart lock installed in my home. So I sent the open instruction, and then it took like 4 hours to open the smart lock. It was going like the long way, like going from my cell phone into the server, and then from the server into like the local gateway for the smart lock, and then from the local gateway for the smart lock, C-Wave into the smart lock, and it took forever. I mean, the door opened when I was gone. So, yeah, there's a mess one.
Yeah, there are also some cases where even the login or the handshake process takes more effort and time than the effort that it will be to perform manually the whole thing.
And so we can do a practice right now, like this. Okay, Google, turn on the light.
Sorry, it looks like 2 lights aren't available right now.
So they got disconnected. Sorry. Well, it's way out.
I remember that there's a protocol called Home Connect, where from your smartphone you can control the appliances of your house. But most of the time, even when it was connected via Bluetooth or Wi-Fi from your smartphone to the device, you have to wait a few minutes sometimes. I don't know what happened at that moment. I was testing the appliances. It was an oven. So the idea was to just prepare popcorn or melt the ice. And it wasn't working. And I was like, oh my gosh, what's going on with it? I thought I had broken the device, but no, nothing like that. But something that when you buy them, the company says, "Hey, you need to buy this, girl. You will be like, your life will be easier." No, it wasn't easier. It is not easier. Sometimes you take a lot of time just to step back the device, and then when you want to control it, it takes a lot of time. So if you're about to buy a device that says Home Connect, don't buy it. Or what? Think about it.
When you were talking about example of the car, for example, the tank is empty, so you get information, something like that. A good example can be, about how to think about the necessity of edge computing or fog computing is like vehicular network. Like you can't really tolerate that much delay to deal with the cloud in certain examples, right? When you're considering network between different vehicles, right? Imagine you're in a turn, there is an accident, there is another, basically, another car trying to communicate and propagate that information. So you can't really tolerate that much delay that the cloud can impose, right? So you want to go with edge or fog computing. Go ahead, Pedro.
Okay, you know that most of these paradigms were born because of the limitation that we have on the network, right? So what do you think about the 5G? Do you think we will have new paradigms, or do you think these paradigms that we already have are going to evolve and have better solutions, or what do you think about it?
There's already some paradigms focusing in mobile, and I think they don't really break their minds creating the name. I think it's mobile computing or something like that. I didn't experience that very in deep, but I know there are already some paradigms focusing in mobile connection. So yes, they are, but I don't really know in deep the information about those. Someone here works with mobile connectivity that could complement this.
I think about where I work, there are guys working with 5G technologies, and they said that right now all the ideas that we have, or all the applications for 5G, they are good and they can work, but first it's needed to install the antennas and the new technology behind 5G. If it's not available, maybe that won't happen. For example, right now, most of the cell phones says 5G, but it's not real 5G. It's 4G, and the guys from the different providers of our cell phone connectivity, they just changed their 4G to 5G just to get more clients. I'm not supposed to say this, but
the new thing with 5G what 5G provide us is mainly the better speed, right? Less delay, and it enables us to handle more devices. So it would make it much easier to have really, really high bandwidth, even in crowded area, which is
an application for these 5G technologies are, for example, that the new automated cars that are coming. Right now, we only know Tesla, but they're coming, for example, BMW, Ford, and other companies that are preparing their products for automotive. And those, for example, I know that the BMW car will host a server, a small server, but well, in fact, two servers, because it needs to have a backup in case the main one fails. And because of these, I don't know, hundreds of sensors, that cameras and all the information that needs to be sent to the server, to the cloud, to process, for example, to sync with the maps or sensing the traffic or things like that. they need 5G for the bandwidth mainly, and also the speed. So those kind of applications are coming for 5G more than we can download a super fast video or something like that. There are more paradigms coming with this, like for example, automotive.
Yeah, and I guess one of the big difference that 5G will really bring into play is that now every device will be addressable via IP, right? I mean, that's something that really breaks everything, that makes everything different. It's not only like having higher speeds with the new antennas that are way smaller and have like less range and whatever, and they will be like invading all of our buildings, but also there are other areas of 5G that go into different frequencies that are like lower frequencies that are not in the gigahertz order, but are in the megahertz order, that are more related to IoT. And the big difference that 5G brings there is that every device will have its own IP and makes everything addressable. So yeah, I mean, that's like the big push and the big idea is that you won't be, I mean, the amount of hops necessary to get into a device will be much less. I mean, the push on 5G is that everything will be more like mist and less than fog, right? I mean, mist in the sense that the very IoT devices will in some way be managed to jump directly into internet, right? That's like the big push of 5G in IoT. But I mean, for us to get there, I mean, we only have right now, at least here in Mexico, we only have like the frequency range separated for that. We don't have anything there. It's just like, okay, 5G will be here in the 700 megahertz range, but we don't have anything there. I mean, it's just like, just keep it there and we'll see what we do for it later on.
Adding to Paul Mejia in the automotive industry. I am in the automotive industry in Continental, and one of the main challenges for the future in automotive is how to connect the cars in a better way to communicate with the environment, like lights, smart cities, and also the autonomous technology. You need to process a lot of data in the cameras. For example, there is a children crossing a busy road. You can't take those images, send it to the cloud, process, and then send the signal to stop the car. It's impossible because you need to react in milliseconds to avoid an accident. So there is a huge amount of data that is producing those cars in the images, in the environment, in the sensor in the cars, the sensor of the tires, the sensor of the climate. There is a lot of information, and there is a challenge actually for autonomous mobility. That is one of the most challenge is the amount of data and how to send to the cloud, and probably fog computing in the big cities and the smart cities in the future will help to solve this kind of problem.
Yeah, to complement David, I mean, I mentioned when you're thinking about vehicular communication, I mean, there is no other way. I mean, we need 5G, we need all these type of paradigms actually. So it can be vehicle to vehicle, it can be vehicle to everything, vehicle to X, they call it V for X. So yeah, that's definitely a great application. I mean, apart from what Rodrigo said, that the 5G paradigm, which by itself maybe it wouldn't be big things, but the opportunity, the application that can enable us, it would be definitely game changing. I mean, definitely not just on the mobile application, but the application that will come later on in the next couple of years based on 5G would be definitely change a lot of things.
Also, the paper mentions that the other way around, instead of manage the cars are as an edge, the cards will be used like a hoof or like a fog layer, because the capabilities of the car to move around the city and acts like a hoof for that kind of application. That would be interesting.
Great. Thank you again, Fernanda, for presentation. Thanks to everyone for participating. So we can have like 5 minutes break, then we come back 8:25, and then we continue with the last part of the paper. Okay.
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 Okay. Start recording. The second part will be presented by Brian.
Yeah.
You can go ahead, share your screen.
If I give you a UX class, can I?
Yeah, that. I mean, if we can all take together, I can consider that.
Okay, you all can see the presentation, right?
Yeah, we can see that. Go ahead.
Okay. Well, this is the second part of the introduction that Fernanda gave to us, and it's called that one needs to know about fog computing and related edge computing paradigms. Sorry, it's something I call it part 2. I call it part 2 something. Okay, well, the first is I try to separate in 4 stages the challenges and the research, the directions that the authors have shown to us. And well, I just present an image about the IoT fog and cloud. And well, I saw that one of the questions were about LoRa. I think Pedro asked that question. I work with LoRa almost every day. And what I can say is that most of the time it's required to have a gateway and then a network server. And yeah, with the network server, you are like, you have more like advantages when you try to work with the data, even when it is encrypted, and then in the network server you can see it also encrypted. You need a next layer that where you can see all the information that you need. I don't know if that answers the question, but all these marks are about security, and you wanna know a little bit more, or anyone in the class, there is something called BridgeD. These guys are working on the standards of LoRaWAN and other protocols. So if you want to read that, that would be great information. And well, I will start. Sorry, I was reviewing the information that I have in the job, and I'm trying to answer that question, clarify them. And well, I continue. The first is foundation, and the authors mentioned the SDN support for FOG. And the first part is what is SDN is software defined networking. And well, what is SDN? I don't know what it is. Just a category of technologies that separate the network control just to enable more automated provisioning and policy-based management of network resources. These are the main limitations of SDN support. And well, the ideas behind the development of SDN are a lot, but I tried to reduce it before. The first is that, well, the main idea is that it promises to reduce the complexity of the statically defined networks. Also, the idea is to make automated network functions much easier and allow simple provisioning and management of network resources. And well, when I try to understand a bit more about VN. I have the link if you want to view it. And I see the key vendors and Cisco, VMware, Juniper, and Big Switch. They are working on this topic. And also on this, the authors mentioned something interesting and said, okay, the use cases of POP is that it's the development of POP computing software. So the vendors play a key role in this. So the idea is that they can add architecture with multiple domains and IoT for DLC and controllers. And foundation, they have a second idea. It's about P2P for computing. And okay, with this, the main idea they try to follow is that create like a results model that can handle heterogeneity and mobility of nodes. And also they consider that P2P is most beneficial when there is no connectivity to the cloud. For example, when there are disasters, the connection to the cloud resources are gone. But here, I didn't understand like 100% what I tried to do, but I found an example. Well, of course, they said that if you use cases are the blockchain technology, keep track of resource transactions. With these two main ideas, in my experience, I worked on a project in 2019 about something called IOTA. This is an open distributed ledger. This is a but this segment for Internet of Things. It uses directed transactions on its ledger, motivated by a potentially higher scalability over blockchain-based distributed layers. With this idea, with focus on IoT ecosystem, I remember that there are projects, I presented one, where we use, we call it pay as you use. Where we use a smartphone, you use a scan of QR code, and you transfer from IOTAs in order to use electricity. For example, well, in 2019, we used to go to the office almost every day. So I remember that I said, okay, I use the router on my house where I use the internet those 6 hours or 8 hours each day. Why Brian is not why Brian trying to pay just 8 hours of electricity? Pay for 8 hours of electricity, and I can use my internet for 8 hours. For me, it's not made from the company, it's not. Well, it wants to look at yes. And if you are interested on one of these IOTAs, it was 28 cents of dollars. So it's kind of cheaper. On 2019, it was like 0.007 cents of with foundation, they say something like a standardized for
Ryan, sorry for interruption. Your voice is a little bit cutting off. I don't know, is your connection, your CPU is super busy, or I don't know, is it maybe my system? I don't know. You guys, you hear him well?
God,
No.
The voice is cutting.
No.
Yeah, you're cutting off. I don't know.
Maybe if you turn the camera off, maybe.
Yeah, maybe you can maybe turn the camera off. Probably you have a low bandwidth. Go ahead.
Okay, can you hear me? Good. Now. Okay. Well, the network is standardized for computing, and there are two big organizations behind it. And well, the main idea here is to have an agreement between researchers and industry, because there are some definitions that are different on the research for researchers, and some definitions are different from companies. So I would like to present the first one. It's called Open Fog Consortium. Well, it was founded on 2015, and the founders have big companies such as Cisco, Intel, Microsoft. Princeton University, Dell, and ARM Holdings. On 2018, the IEEE has announced their standard. It's called Open Fog Reference Architecture. And well, I tried to dig a little bit in the document. It's 160 pages document. It shows examples about the areas of opportunity, different use cases, like the one that one of our colleagues mentioned, that about the smart card, and also the traffic control system. This is one of the main projects behind this idea. And well, they have something really interesting that they said that they try to say, hey, fog and edge are different, like from animation. So they try to say fog versus the cloud, whereas edge is dependent by the solution of the cloud. They try to state that for see the better, see the second that is from Open Edge Computing Initiative. They also began in 2015, and the founders are Vodafone, Intel, and Comcast. With the Intel is working with both projects, and they both in the website they just say grow edge computing. And what they try to deliver is just edge computing platforms and services. These guys are so focused on bring their ideas to the market and trying to sell everything. So they just have try to sell each applications and everything running in the real world. That's their main idea. And well, I continue the second part is mobility. And the authors mentioned that the literature that exists pays little attention to growth, quality of service, costs, and energy consumption. So the main lines of research of energy consumption and reduce distance between fog servers and renewable energy sources. So the main challenge it's first, without energy harvesters include energy consumption, while bringing new challenges in the system. At the other side, telecommunication companies said they should help us identify the location of fog nodes. I can bring power to serve the traffic. And also they say, try to encourage the people to use renewable energy for the against this idea, but that's what they mentioned. So they have the support for high-speed users, but I think
Brian, your voice is cutting off a lot again. I don't know. I'm the only one having problem, or
no?
It's also yeah.
Yeah, it's like
well, the next is support for high-speed users. As we mentioned, this is difficult as a measurement. So here the main limitations are the current communication protocols that are proposed for computer environments.
I don't understand a thing.
yeah. Brian is like it got worse. It got worse. So I don't know. The problem with your connection, or
I think probably it's the microphone is.
Or I think you're now using different microphone because. You know what you can do? I recommend you to log in with your mobile phone so we can have your voice through your mobile phone at the same time. You can I don't know if you have Zoom in your mobile device or tablet, you can sign in, just use it as a microphone and you keep presenting using your computer. You can wait a minute so you can sign in with the mobile. So meanwhile that he's trying to do this, let me share with you something that we need to share. So meanwhile that he's coming, I finalized this name, okay? So, and I locked it. So this can't be changed anymore. So these are the red ones are the one that I put myself. So just to pay more attention to these days. Ricardo, you're quiet. I don't know, you're here still with us, or Ricardo Ray? Yeah, you're here. Okay, you're quiet. Quiet today. So I put your name here, especially your name was missing. So I put your name here and your name, where was that? Yeah, this one, actually. So yeah, so anyway, those reds one are the one I put. So I'm just telling you to remember those dates. But for by any chance, if you had any problem in one of those days, please let me know in advance so I can do something about it.
Sure, thanks.
And what else? And while Brian is solved the problem? Not yet. So the good news I wanted to share with you based on the feedback I received from you, from Pedro Cortes that he was fighting, from Fernanda that he was complaining. Okay.
I wasn't fighting.
It's okay. No. It's okay. So I decided to make this short essays half. So basically what I'm expecting you to submit 5 summaries. Okay.
Okay. Okay, so, whatever we want.
Whichever paper you want. So basically you read one, so that would be included, I assume, because that's you understood it the best. Another one probably you would choose the one that you are basically leading the discussion, because I assume you want to understand that also very good. And you pick another 3, whatever you want. So okay. So that make it literally I cut it by half. So it was 10 papers. Now you submit 5 papers in each for each essay. Okay.
Okay. Thank you.
Yeah. So I hope that helps. So you don't really suffer much. Okay. That's not what I'm looking for to make you suffer. So Brian, you're back. You can go ahead and share, and let's see if the problem is solved. Brian, can you hear us?
Yeah, I can hear you. I will share the screen in just a second.
Yeah, your voice is much better now. What you did?
I just use my cell phone.
Okay, yeah, that you can use both. You can use also, yeah, you can share it now with your computer and use this one as a.
Okay. Okay, you can see the. Okay, well, I was on support high speed for high speed users, and well, where it was, well, the line of research that the authors mentioned is that the use of machine learning mobility prediction algorithms in the design of the handshake and authentication. They said that the main idea is to predict the location of high-speed users and analyze their mobility patterns. And well, they mentioned also IoT applications, the provisioning for IoT applications. They say that it's required to be dynamic and proactive due to the rapid changes. So as said, these changes are from connectivity, bandwidth fluctuations, and failure. in different IoT environments. And well, here I was like, it's too difficult because we depend 100% on hardware. For example, you want to communicate via 5G, 4G. We need a good coverage from the different antennas and different providers, and also use the best chipsets for the best chipsets for 4G, 5G. So it would be kind of difficult, but yeah, maybe somebody's working on that, and it's kind of cool. And well, then the main concerns are about security, and the authors say something really interesting. They say that the fog nodes are about to be placed near users in locations such as base station routers, and the most common is close to Wi-Fi access points. So they say the line of research to follow is to design strong access control policies for fog nodes. And so they will give us an idea of the malicious users. But the main concern here is that clients, usually the offloads in a task, are needed as a fog node. So if somebody like a malicious user is trying to get information, they will know not just where we are, they will know the closest node. They can see the traffic over there. And well, also with security, this is kind of related to the last one. And they say, okay, offloading task from fog nodes may incur in some security and privacy risk. So most of the time when we share information, we can share security and critical or privacy information. And so people can get that information, and it happens when a fog node becomes overloaded. So that's when we are under risk, or this is the moment where information from us can be obtained from malicious users. They propose a solution, so I asked just the question mark, like solution, because I don't consider the best solution. They say just design a lightweight and efficient mechanism for IoT receivers to verify the correctness and integrity of the offloaded task. I haven't seen that kind of solution with IoT devices. We can discuss that later. And well, also, okay. And well, then we have the resilient fog security system, where the main limitations are attacks, since fog nodes are more resource constrained than secure cloud data centers. And also, the recently compromising IoT nodes and embedded systems are becoming new sources of distributed those attacks. Yeah, sometimes with embedded devices, it's kind of difficult to apply to work with security, because most of them just take information and push to a specific server, send information to a specific gateway, so information can be taken in that place. And well, the use cases here, they mention a stream of data. They said here it's about providing extra replicas of those functions. But on the other hand, due to the limited computing resources of computers, the allocation of the function replicas and provide availability is not a straightforward decision. So here it's kind of a problem. And then they have, well, this is one of the last topic. It's about IoT. And then they mention green fog computing. They just mentioned the use of energy harvesters or energy-aware fog node replacement. So they said, the lines of research here is just about improved energy consumptions while bringing new challenges to the system. Here, their solutions, they say reduce the energy consumption of fog nodes, and identify the location of this node. And here I can talk with my experience with using LoRa and other protocols such as Sigfox. Most of the time, when we talk about green energies, it's not green 100%. We just say here we have batteries that can last until 3 years. So 3 years is a lot. And we send, they say most of the time it's about to send a message every 1 hour just to save energy and also just to monitor some specific task. For example, I was working on a project where we get information from a place where, a place in a manufacturing site where different chemicals were over there. So we try to get information from temperature, humidity, and information every hour. So first, our device was using batteries, so we can keep the battery life longer. And then you just need few information, less than, well, some protocol says less than 12 or 8 bytes. So I think that's a lot of information. And you can just save battery this way. Yeah, you can use solar panels and everything, but it's not reliable and it's more expensive, at least talking about IoT devices. And well, as a conclusion, we can say like a fog computing is a promising solution for handling big data produced by the end devices, or in this case, IoT devices, which is often time sensitive. Yeah, sometimes we need information, we need accurate information and precise time. The advantages with the number of connected devices and IoT networks is continue going up. So more companies are deploying more devices and more people is in this game about IoT. So I think it's going up, more job for a few years. And well, that's all from my side. Sorry for the problem with my voice.
No problem, Brian. Thank you so much for presentation. It was good because you have a lot of experience on IoT devices. So let's hear the discussion.
Madi, I have a question about this. It's about OpenFog consortium that Brian said it's among Cisco, Intel, Microsoft, Princeton University, Dell, ARM Holdings. I found the same statement at the paper I read, and it says is to promote the development of fog computing. But there is any kind of business model in the back. There is something about business related.
Do you mean if it follows like a business, or can you repeat that question again?
Yeah, this consortium, this OpenFog consortium among Cisco, Intel, Microsoft, in the paper I read, it says is to promote the development of fog computing, but that's it. There are no references, there are no more purposes. I am asking if you know, if you feel, if you believe there is something else beside this purpose of just development of fog computing. I mean, there is some kind of business model.
That you're asking if there's like some economic motivator in the back that says,
right.
Hey, just
correct.
go on and follow. Yeah, no clue, probably.
Well,
no, you can bet that there is a economic motivation, and I can tell because I was involved in a validation of a product that was focused on 5G, Intel, and the plan is to continue the across the next generations of the same product, focus on 5G, and Intel developed this with all the features that are interested in communication, telecommunication. And as far as I know, there are this kind of, for example, this consortium that you mentioned, Microsoft, the biggest company, the high-end companies, because they like sit down in a table in a meeting, and well, it's simple words, but they put their ideas to standardize the next technology. Right now it's 5G, but I can assure you that they're thinking already in the next one, and two technologies ahead. So and this is something that I can assure you because
it's a good point, the standardization of the technology. That's a good point.
Yeah. And the main purpose of this kind of agreements are the money. They sell the technology. So if they own the standard, they can sell their own technology.
But at the end of the day, they are doing this because they can later be sure that their products are part of that. In this case, their products can support the fog, right? They can do that service. So that's the reason that, and like Paul said, they always want to standardize so their products can work together. So it doesn't matter if someone has a Cisco product and someone else has another company product, and they are pretty sure that they are going to work fine with fog because the companies are already enrolled on that service, right?
And it goes beyond, because let me put you an example. Right now there are the fight for the silicon, like Intel versus AMD, for example. And some people say that, and it's a fact also, that AMD has better CPUs these days, faster, more cores, blah blah blah. But in the hardware, but how about the integration? For example, Microsoft works directly with Intel, and also they validate a lot more than AMD. And when Intel releases its products, they work better because the cooperation and the validation happened in the development stages. And even though if AMD has better hardware, they perform Intel Silicon outperform AMD because these previous steps, and so for example for fog, there can be so many manufacturers, but not all of them are validated and integrated correctly. So the ones that perform better are the ones that are sold across the market. That's why it's important that they put like an agreement on how they will be developing the technology.
Okay.
Also, Doctor, something that is happening now, it's, for example, some companies sell IoT devices at the lowest price, but if you realize what the company, you said, oh, the devices are cheaper, but the main idea from them is to get a lot of information. So they have a bunch of data scientists and data analysts working with this information. So then the company say, hey, we have this service. This is about analytics from your environment or from your site. So you said, oh, okay, maybe you need it. But this where the information was gathered, from you. And then they try to sell more services. That's the main business that they have. And also there exist companies that also give you the devices, that they say, hey, these devices are for free, use them, and you place the devices from in your office or at your house, and the information you have it on your cell phone, yeah, but also the company has it on their servers, and people is working on the next generation of the devices. And most of the time, these devices look like a finished product, but these products are not finished. They are under testing. So testing is just about get information and try to see if the device is working correctly with the sensors or anything that they have. So yeah, it's something curious right now.
Yeah, that's why the Alexas are so cheap.
Just drop there in the chat about this smart home company that is named Tuya. They have like basically you dropping into their platform and you start like using their services, and they can start like giving you away like smart lights and smart cameras and stuff of the like. And they supposedly have an open API, and you can go on and check it out. I mean, it is very sketchy if all the API is written in Chinese. And also, I think what is worse is that whatever you buy in Steren that is smart, it is also from Tuya. So I don't know.
Also, you see it. I don't know if you read about it, but a few weeks ago, Amazon bought Roomba. So now you have Amazon has Roomba, has different the likes, Alexa, and more stuff, and your house is almost 100% controlled by them. So
monopoly.
Yeah, at the end, Amazon will recommend you a lot of stuff, and you say, oh, okay, maybe I need this. But how did they get information? This is something that some people is fighting with them. Like, hey, no, you cannot use my information. But on the policies, you always say, hey, accept, and they have the information. So they are able to recommend you whatever they want. And now they also can recommend you the use of how you clean your house. They said, oh, maybe you need this, I don't know, soap or
the only thing they didn't know how you furnish your house and how you put things inside your house. Now they know that.
Yeah,
but even with
house, yeah.
Even with Roomba, they can know the measures of your house.
They measure the structure of the house.
Yeah.
Yeah.
And you see, at the end, they will recommend furniture, and maybe you don't need the furniture, but you will buy it because they look cheap, it looks good. So at the end, yeah, you will buy everything from Amazon. I'm not trying to scare anyone.
You have a seller living in your house.
Yeah, just wait until you can just like push into a REST API and trigger a Lambda, and the Lambda starts the Roomba. I know that will happen eventually.
What else? More question, Fernanda?
I have another question, but I hope it's not very hard. The concept of ecology always catches my attention, and since the article talks about this green computing, I wonder, does it only cover like, the classic make the batteries live longer? Does it cover anything else? I mean, does it attack other issues or just batteries? Do you know that, or someone know that, Dora? How can make this ecology more obvious and not just with the battery lives?
I think I have an example. Well, you said you stay in the IoT class. I was not in there, but for example, LoRa has 3 types of devices. They said device type A is battery powered device, and it just sends a message, not frequently, just sends every hour or every 2 hours or once a day. Also, you have device B that it's powered up by batteries, but it works more frequently than device class A, and you have device class C that it works directly plugged into to the outlet. Here you can say that, okay, when the device is dedicated, so with the device dedicated, it works directly plugged to the lights. And well, some applications, for example, I don't know, in forests or in cities, you see all of the time they have a small solar panel, but they are also powered up to electricity. So by electricity, sorry. So it seems like you always will need a battery, which is not good for the environment. Yeah, all the devices on IoT at least, all of them have a battery, even when they are powered up. For example, when there is no electricity in the city, battery is working. But at the end, you said, okay, it's working with two different power sources: battery, which is it pollutes a lot, and also use electricity. It's polluting from both sides. So maybe right now they are not focused on working on this, or the companies and researchers maybe are not working on that. They are working on how to have relay information at a specific time and just be, I don't know if this is correct, but be 100% and the connectivity is from both sides, from the end device to the cloud, for example.
I think that there were like in the past paper, the one that Octier was presenting, they say that, for example, computing takes a lot of energy, you know, like for example the Bitcoin, the mining thing and that kind of stuff. So what they say is that maybe instead of you know, doing a lot of computing in just one device, you can take other devices and take the idle that they have and start using that idle. So you can, you know, they are already using energy. So instead of just using one that is going to take a lot of energy, you can use the ones that are also running and doing nothing. So they can help to computing, right? So this is like a algorithm that they are implementing, so they can take less energy when they are using fog.
Yeah, and I also think that unless the energy, well, the energy from fossils right now, it's like cheap, and also from carbon. So unless that changes, I don't think they're going to invest much in green energies, like unless they see like a big trade-off here, like using green energies to like some, I don't know, I think some countries are like if you use some green energies, you don't need to pay so much taxes or so. So they make you like cheaper green energies, but I don't think there's going to be much progress there unless this kind of incentives are given.
Also, you see, for example, crypto, I think it represents just 3% of the total amount of energy. Yeah, it's 3% of total amount of energy, so it is not much. And there are examples of countries like Iceland, where it will be easy to mining crypto, because they will use geothermal energy, because they have lots of volcanoes and it's tough working there. So it means that maybe we will reduce the amount of energy used by mining. So it's a good way to see it.
Yeah, but I think it's more like the approach is more like doing better algorithms and more efficient, that they can take advantage of the hardware that they already have, instead of just letting some hardware without doing nothing and just putting all the computing in just one part of the edges.
Yeah, I think one of the main issues there is that, I mean, there are tons of things that still can be optimized, like we said, like latency, like energy consumption, like, I don't know, like where to place computing resources. And the thing is that, like in cloud computing, we already have like PaaS, right? And we don't and we have an elasticity and tons of frameworks that do that heavy lifting for us, in that we don't have to think a lot on how to place things or how to better optimize it. And I think that until we really need to get onto that point in which we can just start leaving that heavy lifting to someone else and only focus on the application. But yeah, I mean, that's the main reason why we have all these efforts, right? Of the Open Fork Consortium, of like the standardization of the APIs. And again, right, we see like a lot of variety of papers saying, I want just to optimize energy. I want just to optimize the other one. I guess that there's like a need to really focus efforts in one sense, and just for a then second, forget about making money. But yeah, I mean, that's how things are.
Someone has another question that wants to ask. Also,
Okay.
I was
Yeah. Thanks a lot, Brian, for the presentation, and everyone for participating. Just wait a minute. I'm doing something. I want to ask you a question. I'm trying to see if it's working or not. Why it's not working?
Yeah. What is not working, Mari?
Yeah. Let me see if it's working or not. Yeah. Create. Edit. No, it's not working. No, I wanted to ask you a question over Zoom, but it didn't work. Yeah, it's working actually. But I don't know how does it work. Apparently I have to edit the questions in, oh, I got it. So it's about crypto, okay? That do you do any inversion, any trading or investment in crypto? Just a minute. Because I want it to be anonymous. So then I can practice this. Yeah, I appreciate if you answer this. It's anonymous, so don't worry about it. I want to see how things goes.
Just one question, Madi. Is it that currently we're investing on
currently,
or that we have done it?
No, currently.
Yeah, I jump out of the boat. Okay.
Any prediction with the Ethereum merge?
So yeah, I was just curious, honestly. So what I'm seeing here, I mean, for your information, if you want to see also, if you're curious to see, do you see the results or you don't see?
No, don't see.
No. So if I can share with you the results. Is this one? So 1/3 is doing investment or trading, and 2/3 doesn't do it.
I can only see the.
We only see the presentation.
Yeah, the
docs, the Google Docs.
Yeah.
Yeah, this one. Yeah, you see it, right?
No.
Only Chrome.
You just you don't see it.
No.
Don't.
Maybe you can take a screenshot and then. Oh
Yeah.
yeah, right
Ah,
now.
okay. Let's take them. So yes, like basically 33% doing, 67% not doing it. It was just curiosity, nothing related to this.
What about you? Do you do crypto?
No.
Any reason?
It was anonymous, Pedro.
No, I don't mind sharing. No, the problem is from your side, actually, like that I can't really, maybe you don't feel comfortable sharing, but from this side, I can share without problem. But no, I don't believe, I don't do, no, though I'm, let me